What we're looking at is how to find two things. The first is the angle that a line makes with the positive direction of the x-axis. And then the next thing is finding the angle between two lines. So let's jump into it. This black line we've got here is 2/3 x plus 1. So what we can do is we need a bit of calculus for this. We're just going to take the derivative. So the derivative is going to be 2/3, using the power rule. So what we can say about the gradient of this line, if we call this line 1, the gradient is equal to 2/3. And what I want you to think about is, that the tan of some angle must be equal to the gradient. And this should hopefully make a bit of sense because, for example, if I was to make a triangle here, 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 you would agree that the gradient is rise over run. So that's, in this case, it's this length divided by this length. So the ratio of this length to this length is opposite over adjacent, which is tan. So it's, 2/3. The ratio of this to this is 2/3. So, hopefully you can see why tan of some angle is equal to 2/3 in this case, equal to the gradient. And then, what we can do is we can solve that. So we take tan inverse of 2/3, and then we work that out. So if we go to trig tan inverse of 2/3, and then press enter, we get approximately 33.69 degrees. So that angle in there is 33.69 degrees. And we can actually check that. If I go angle, click this, hopefully we got this right. Yeah, we can see that it's approximately 33.69 degrees there. Okay, the next interesting thing we want to do is we want to think about lines that slope in the negative direction because they're a little bit trickier when we're thinking about the angle. Because one thing I just want to point out is that was with the positive direction of the x-axis. So it's the angle created going around from the line to the positive direction of the x-axis. So that's this part here. Okay, but you might be wondering what happens if we have a negative line. So we've got this red line, for example. Let's see what happens in this case. So in this case, we've got y equals -1/4 x plus 1/2. That just happens to be the equation of the line, could be anything. But you'll notice now the positive direction of the x-axis is going to be this angle here. So that one's a little bit trickier to find out, but we're going to apply some similar logic and let's see if we can work it out. So again, take the derivative. So dy dx equals -1/4. Okay, now the same thing, do the exact same thing. Take tan of a tan of some angle is equal to the gradient. Now the gradient is equal to -1/4. So in this case here, the triangle that we'd be creating would be this triangle in this case. Because it's sloping negatively, would get -1/4 as our gradient there. So what you'll notice is, if we get going, we'll get, this angle in here is going to be tan inverse of -1/4, which is -14.04. So let's just check that. Tan inverse of -1/4 is -14.04 approximately. Okay, that's not the angle we're interested in. You can probably guess we don't want this angle. We want this angle. This is the angle made with the positive direction of the x-axis. So you might consider that this angle here and this angle are supplementary. So they must add to 180. So if we do 180 minus this angle, that's going to give us, the angle that's created is 165.96 degrees. So we can also check that. If I go angle, if we find this angle here, 165.96. So that checks out. Okay, now the last thing you might be wondering is what's the angle created between the two lines? So what's this angle here in this case? And we can also work that out. So I might make another video explaining why this is the case, but basically the angle between two lines is basically given by θ2, take away θ1. I encourage you to pause and think about why that might be the case. But if you take this angle, 165.96, and subtract this angle, this will give you this angle in here. Okay, so let's see what that gives us. 165.96 minus 33.69 gives us 132.27. And then lo and behold, if I go here, here, and here to find that angle, 132.27. So this is not difficult to prove. We haven't proved it in this case, but yeah, that is how you find the angle between two lines. You take, the second angle, you take the second angle with the positive direction of the x-axis minus the other angle with the positive direction of the x-axis, and you'll get that as your answer. So hopefully that clarifies things a little bit. So a bit of calculus, bit of sort of coordinate geometry stuff going on there, but hopefully that makes a bit of sense.